Hello, my name is Haley Brooks, and today I'm going to be presenting on Tourette syndrome. And I just wanted to let you know that if you see a star anywhere in my presentation, that means that it's class content that we've gone through over the semester. So first, what is Tourette syndrome? It is a neurological disorder that causes sudden, unwanted, and uncontrollable movements or vocal sounds. This includes motor tics as well as vocal tics. So some examples of simple motor tics are body movements like blinking, eye movements, facial grimacing, shrugging, head jerking, or nose twitching. And simple vocal tics are throat clearing, sniffing, barking, grunting, or squeaking. And then some complex motor tics include coordinated patterns of movement that involve several muscle groups and are usually multiple simple motor tics combined. And then some complex vocal tics are the repetition of their own words or phrases, as well as echolalia, which is the repetition of another individual's words or phrases, or coprolalia, which is the use and repetition of cuss words when tics are expressed. So, my first question was, what areas of the brain are activated when tics are expressed? And researchers use PET scans in order to record this. They found that the brain activity that was recorded when tics occurred were in the frontal lobe, temporal lobe, parietal lobe, as well as in the insula, which is under the temporal and frontal lobes in the succulus. And if you can see my pointer, it's right around here. This led me to wonder what causes severity of tics and Tourette syndrome. Researchers investigated thalamocortical osculatory connectivity, which is neural activity between the thalamus and cortical regions of the brain, by combining recordings from an implanted thalamic deep brain stimulation target using a neurostimulator. So here's the deep brain stimulation, and down here you can see the neurostimulator, as well as a high density EEG, which can be seen below in participants with Tourette syndrome. They found pattern linking the medial thalamus with frontal regions of the brain. So whenever the areas were strongly connected, tics were less severe, and when the areas were more weakly connected, the tics were more severe. Therefore, they believe that the thalamo-frontal alpha connectivity is involved in tic generation and severity. My second question was, can cortisol levels affect Tourette syndrome? So when they researched children with Tourette syndrome and compared them to children without Tourette syndrome, the children with Tourette syndrome experience higher levels of anxiety, and they also showed significantly higher levels of cortisol, which reflects the heightened responsivity of the HPA axis in response to stress. And just as a reminder, the HPA axis is where the hypothalamus signals the pituitary gland to signal the adrenal gland and the kidney in order for it to release cortisol. They found a negative correlation between the high cortisol and the number and severity of tics. Therefore, they believe that it's plausible that tic expression can actually result in stress reduction, leading to less cortisol secretion. My third question was, what are the heritability and concordance rates of Tourette syndrome? So it has a strong genetic component, with heritability rates estimating a range from 50 to 80%, and then up to 57% of parents with a child with Tourette syndrome also have a history of some form of tics. 15 to 20% of first relatives, which can include biological children, biological parents, or full siblings, also have a chronic tic disorder, which is a milder form of Tourette syndrome. And then in twin studies, the concordance rates for monozygotic twins is 50 to 70%, meaning that if one of the monozygotic twins has Tourette syndrome, then there's about a 50 to 70% likelihood that the other twin develops Tourette syndrome. And then for dizygotic twins, it was 9%, meaning if one dizygotic twin had Tourette syndrome, then there's about a 9% likelihood that that other twin has Tourette syndrome as well. And here are my references. Thank you very much for listening to my presentation.